طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه ومن والاه. عيدكم مبارك first of all. الله يتقبل منا ومنكم إن شاء الله. Any questions يا شباب before we proceed? Any questions before we proceed? Okay. طيب, so inshallah today's topic is the last topic in the semester. Alaykum assalam wa rahmatullah. And inshallah we will finish everything today. So there will be no classes on Tuesday and Thursday. Okay. Today inshallah we will finish everything. طيب. So what we will do today is we will consider solving linear recurrence equations. Now, we saw how to solve a recurrence equation if it was kind of the form like an equals something multiplied by an minus 1. So we saw how we can solve this. We basically use expansion, iterative expansion, and we come up with a solution, right? We come up with a solution. Now, what we will do is we will look at a more general case, okay? A more general case. We will not go too general, okay? We will only consider solving a linear homogeneous recurrence equation with constant coefficients, okay? Now, what do we mean by that? We'll talk about it when we define a linear homogeneous equation. So linear non-homogeneous recurrence relations with constant coefficients are omitted. And it will be enough for us, especially those related to estimating the complexity of recursive algorithms, to just study, linear homogeneous recurrence equations, of degree k equal 2, right? So we will take theorem 1 and theorem 2 are related to k equal 2. Theorems 3 and 4 are for general case. We will not look into that, okay? We will not look into that. So let's start. So what is a linear homogeneous recurrence relation of degree k? Well, it's basically of the form an equal c1 an minus 1 plus c2 an minus 2 plus all the way plus ck an minus k, where c1 with c2 all the way up to ck are all real numbers, are all constants, and we require ck not to be equal to 0. If I want it to be of degree k, then ck has to be non-zero, okay? Then we say that this is a linear homogeneous equation of degree k. طيب. So what are the forms of like non-homogeneous recurrence equation? Well, if you basically, for example, if after this you have plus some other constant, so it is not multiplied by a some n minus something. Well, in that case, it will not be homogeneous. Okay, in that case, it will not be homogeneous, and it is linear because what's the power of an minus 1 an minus 2 an minus 3 لغايه ال an minus k؟ ايش الباور تبعهم؟ كلياتها واحد. Okay, all of them are 1. Okay. طيب. So basically, what we will be doing is we will be looking at this type of recurrences only, اللي هي of degree 2. Okay, we will only consider linear homogeneous recurrence relations with constant coefficients with k equal 2. So whenever you see an equals c1 an minus 1 plus c2 an minus 2, how do we solve it? Well, the first step in the solution is to come up with what is called the characteristic equation. What is the characteristic equation? Well, look here. Basically, what is the maximum history here? An minus 2, صح? Right? So this is of degree 2, right? So basically what you do is starting from an, this will be of degree 2, this will be of degree 1, this will be of degree 0. Okay, so let C1 and C2 be real numbers. Suppose that r squared minus C1r minus C2. This is my characteristic equation. Okay, so basically, so in this case, characteristic equation is, since the degree here is 2, so I would say, for example, r squared equals C1 r plus C2. Okay, so that you don't make a mistake. Look at this and look at this. Are they the same? They are the same, huh? They are the same. And they are the same in both, in theorem 1 and in theorem 2, huh? The characteristic equation is the same. So what is the difference between theorem 1 and theorem 2? The main difference between theorem 1 and theorem 2 is that theorem 1 deals with the case when the roots are distinct, are different. So you have two roots. Okay? Since this is an equation of degree 2, you have two roots. Huh? If the two roots are distinct, theorem 1 will give us a specific solution. ايش هو السوليوشن? Well, the solution in that case will be, if R1 and R2 are the roots, alpha 1 R1 to the power n plus alpha 2 R2 to the power n. And what is the second case? Well, the second case is that the roots are multiple, meaning it's one root, صح? One root repeated. Okay, one repeated root. In that case, what will be the solution? The solution will be alpha 1 r to the power n, or since here r0 meaning that we have only one root, so r0 to the power n plus alpha 2 n r0 to the power n. You have to memorize these two solutions. They will not be given to you. Okay, you have to memorize these two solutions. طيب. Now I have alpha 1 and alpha 2. What are the alpha 1 and alpha 2? The alpha 1 and alpha 2 are constants. How are we going to get them? From the initial conditions. We are going to get the alphas from the initial conditions. The lecture is over. اللي هي initial conditions when I tell you an equal, for example, an minus 1 plus an minus 2, بعدين أقول لك a0 equals something, a1 equals something. Huh? So let's take an example. The material of the lecture is finished, by the way. We are done. Okay, this might be the smallest the smallest lecture. Right. So solve these recurrence relations together with the initial conditions given. Okay, so an equal 4an minus 1 minus 4an minus 2 for n greater or equal to 2, and then a0 equals 6, a1 equal 8. Right. So let's start with the characteristic equation. Who's going to tell me what is the characteristic equation in this case? R squared is equal to 4r minus 4, صح? Which means r squared minus 4r plus 4 is equal to 0, صح ولا لا؟ طيب, what's the solution to this? R is equal to repeated twice, huh? What is this? Isn't this the same as r minus 2 all square equals 0? It's the same, huh? R square minus 4r plus 4 equals 0. So therefore, how many roots do I have? I have one root which is repeated twice, or multiple of multiplicity of multiplicity 2. So what do? We apply theorem 2. So by theorem 2, the solution is an equal alpha 1. ايش الار؟ احنا قلنا r is equal to 2 صح؟ alpha 1 times 2 to the power n plus alpha 2 times n times 2 to the power n. That's the that's the solution. إذا كان في term ثالث إيش قصدك؟ يعني يعني an minus 3 مثلا. Well, هذه it will be taken care of in theorem 3 or 4, which we will not worry about. We will just concentrate on k equal to, degree equal to. Okay, but if you're interested, just look at 3 and 4. And by the way, it's basically a generalization of this case. يعني nothing that is too what you call too complicated. It's not complicated at all. Okay. Yes. We use theorem 2. We don't use theorem 1. We use theorem 1 when the roots are different. When the multiplicity of each one of them is 1. Yes. Okay. So now what is left? Alpha 1 or alpha 2. I need to find alpha 1 or alpha 2. How do I find alpha 1 or alpha 2? Well, since A0 is equal to 6, then 6 is equal to A0. عوض بالN 0. ايش أول شيء بيعطينا؟ Alpha 1 times 2 to the power 0 is alpha 1, right? Plus 0. اللي هي alpha 2 times 0 times 2 to the power 0 is basically 0. So therefore, alpha 1 is equal to 6. طيب ال A1, what is it equal to? 8, صح? So I have 8 equals. Now, alpha 1 times 2 to the power 1, صح? So this is 2 alpha 1, okay? Plus alpha 2 times 1 times 2 to the power 1. So this is plus 2 alpha 2, صح? This is equal to 8. طيب, alpha 1, I already know alpha 1, right? So I can plug in alpha 1 here in 2 alpha 1. So therefore, 8 is equal to 2 times 6 plus 2 alpha 2, which is 12, صح? So 2 alpha 2 is equal to 8 minus 12, which is minus 4. So alpha 2 is equal to what? Alpha 2 is equal to minus 2. So now I have alpha 1 and I have alpha 2. So what is the solution to the recurrence? An is equal to what? 6 times 2 to the power n minus 2n times 2 to the power n. صح ولا لا? Minus 2n times 2 to the power n. Of course, if you want to simplify it like 3, 2 to the n plus 1 minus n 2 to the n plus 1, you can also do that. Okay, you can also do that. So we're done. Okay, so let's take now the second example before we go to the activity. So this one is from question 2, page 508. An is equal to 4an minus 2 for n greater equal to 2, and a0 equals 0 and a4 is equal to 4. Who's going to tell me what is the characteristic equation? أيوة. R square equals 4 صح؟ في R؟ ما في R ليش؟ لأنه this is an minus 2, this is not an minus 1, right? This is an minus 2. So basically the coefficient of an minus 1 is what? Is 0, صح? Is 0. So this is still a linear homogeneous equation, right? A linear homogeneous equation of degree 2. So R squared equal to 4, which means that what is my equation? R squared minus 4 is equal to 0. طيب, R squared minus 4 is equal to 0. How do we solve this? مش هذه نفسها R minus 2 times R plus 2 is equal to 0. Huh? So how many roots do I have? 2 distinct roots. صح? So therefore R1 is equal to ايش? 2. R2 is equal to minus 2. Does it matter if I say R1 equal, for example, minus 2 and R2 is equal to 2? It will not matter because the alphas will basically change, صح? So we will finally get exactly the same solution. We will get exactly the same solution. طيب. So R1 is equal to 2, R2 is equal to minus 2. Which theorem do we use? 1 or 2? We're going to use theorem 1 because we have distinct root. So by theorem 1, the solution is an equal alpha 1 R1 to the power n plus alpha 2 R2 to the power n. Alpha 1 R1 to the power n plus alpha 2 R2 to the power n. طيب. عليكم السلام ورحمة الله. يلا ايش نسوي هلا؟ Initial conditions, right? Since A0 is equal to 0, we have 0 equals أيوة alpha 1 times well, the solution is oh, I didn't write. طيب معلش خليني, let me okay, which is alpha 1 times 2 to the power n plus alpha 2 times minus 2 to the power n, صح? So this is my solution. I just plugged in R1 and R2. So now I can say since A0 equals 0, we have 0 equals alpha 1 times 2 to the power 0, alpha 1, plus alpha 2 times minus 2 to the power 0, alpha 2, صح? So this is alpha 1 plus alpha 2. طيب, what about A1? Well, A1 is equal to 4. So 4 is equal to. Now, if I plug in 1, إيش عندي هنا? 2 alpha 1 minus 2 alpha 2. 2 alpha 1 minus 2 alpha 2. How do I solve this problem? I have a system of linear equations. Huh? So I can basically multiply this by 2 and then add them together, right? So if I multiply by 2 and add them together, 2 times 0 is 0, so 0 plus 4 is 4. 2 times alpha 1 is 2 alpha 1. 2 alpha 1 plus 2 alpha 1, 4 alpha 1. 2 times alpha 2 is 2 alpha 2. 2 alpha 2 minus 2 alpha 2, 0. This is what we wanted, right? So 4 alpha 1 is equal to 4. This implies alpha 1 is equal to ايش? Alpha 1 is equal to 1. Now I can use whichever equation. Of course, it's easier to use the top one, صح? So therefore, alpha 2 is equal to ايش? Alpha 2 is equal to minus 1. So what is the solution in this case? Therefore, the solution is an equal الالفا 1 اللي هي 1 صح times 2 to the power n minus 2 to the power n. صح ولا لا؟ minus 2 to the power n. This is the closed form solution. Yes.
The difference between theorem 1 and theorem 2 is that the second term we multiply by n for theorem 2.
Yes, because in see the first one when the roots are distinct it's very simple. Alpha 1 r1 to the power n plus alpha 2 r2 to the power n. صح؟ طيب هلا if the roots are the same then it will be alpha 1 r1 to the power n plus alpha 2 n r1 to the power n. Alpha 1 r or r0 because you have only one alpha 1 r0 to the power n plus alpha 2 n r0 to the power so you have to memorize these two solutions. Okay, these will not be given to you. واضح يا شباب؟ Okay, ready for the activity. So now this time the activity looks like a quiz. It has two questions on the front and the back. Okay, so it will not take you much time. In fact, I think this will prove to be the quickest lecture. Huh? But can you come here? Okay. Would you like to go 3? Yalla, go 3. Okay. So please make sure that you write your names and IDs on the paper, and of course, when you submit to Gradescope, make sure that you include your all the group members, right? If you don't, it's not a big deal. As long as I see your names on the paper, I can do it from my side. يعني بس راح تغلبوني هيك ها. You can go to. You can go to. Continue here. Would you like to go 3 then? يلا. معلش. Okay.